10.1, scatter plots and trend lines. What you will hear with this a lot is line of best fit as well. We've kind of addressed a little bit, talking about correlation coefficients and looking at scatter plots. We're going to do a continuation of that here using the calculator and also analyzing some given data. So one of the things that, again, we want to refer to here is what we call our correlation coefficient, and that is our R. And we want that close to -1 or 1. And the closer it is to that, the better the line of fit. If the value is closer to 0, then what we typically refer to that as no correlation. The reason we do -1 or +1 is depending on how the scatter plot is laid out. So is it going down or is it going up? If it's going up, then we want the value close to 1. Going down, we want it close to -1. So in these particular examples, what we're going to do is we're going to look at how closely the line is. So here we say this one is R is close to -1 because it is going down, but also because the points are relatively close to the line. Whereas this one is more closely, probably we're going to look later on, but we would say -0.5. It is going down, but you see the points are a little bit further away from the line. And then we take an example. So again, over on this other side here, sorry about that, we have close going up, so 1 going up still, but further away, so that'd be +5. But then you get to one like this, and there's really no correlation. There's not a line. I'm just going to draw some lines here. There's not really a line that you draw that, demonstrates a good fit one way or the other. You've got points all over the place. So we would say that one's close to really no correlation. All right, so let's take a look at these your turn examples. So if I draw a line here, okay, and again, you're going to have multiple lines. That's why we use the calculator to get one given all the data that is a best fit. Everybody gets the same thing. But if I look at that one, those points are relatively close, but not really, really close. So I would probably say that one's a 0.5, so 0.5. And again, it's positive because it's going up. You don't have to put the positive. This one, if I draw, those points are really actually pretty close to the line. It is going down, so I would say that one would be a -1 would be its fit. Okay, so for this particular problem, we're given our data points over here, and first thing we're going to do, we're going to make our scatter plot. So we're just going to plot our points, and again, pay attention to your labels here so you know what's X, what's Y. It's pretty straightforward. So at 0, we got 2.1, so we'll just go slightly above that. 1, we're 4.3. 2, 5, and again, obviously these are not going to be exact. We're just doing the best we can. 3, 7.3, I don't know, maybe there. 4, 8.1, so, and then 5, 10.2. Okay, so this is make a scatter plot, find the line of fit. If the variables have a correlation, what is the equation of your line of fit? Okay. So these obviously have a correlation, a positive correlation. And I would even go as so far as to say that it is a +1 is our best correlation coefficient here. However, if you're going to find a line of fit, my suggestion is pick 2 points and draw your line. And it doesn't matter which 2 points you choose. You just want to find 2 that get really close. So I'm going to take these 2 right here, and these are going to be my 2 to draw my line. Now, to get your equation, all you do is just take those 2 points. So I use this point here, and then I use this point. So find your slope. So how do you get slope? Change in y over change in x. So I got 8.1 minus 2.1 over 4 minus 0. That would be 6 over 4, which would reduce to 3/2. So there's my m. And then my b is my y-intercept, which is one of the points I chose, which is 2.1. So b is 2.1. So then my equation becomes y equals mx plus b. And there's a line of fit. And really, anybody can get different equations for lines of fit depending on what points you use. Again, that's why we're leading into using the calculator, because with the calculator, we're going to use all the points, and it's going to create a line equation that fits for everybody. Everybody's going to get the same answer. So it says, use the model you constructed to predict how tall a Elfie's tree will be 10 years after she planted it. So again, what was our equation? Y equals 3/2 x plus 2.1. Now at this point, what you can do is put that in your calculator. So I'm going to turn my calculator on. I'm going to go to y equals. I'm going to type in my equation. And then I'm going to go to my table, and then I'm going to scroll down to 10 and look at my prediction. So when x equals 10, y is predicted to be 17.1. So that's how you use your line of fit. Lines of fit are used to make future predictions. Now, what you've got to understand is a line of fit is not the exact answer. Okay, this is not exact data because, again, it's our line of best fit. It's not the exact fit. All right, this next one. HDL cholesterol is considered the good cholesterol as it moves harmful bad cholesterol from where it doesn't belong. Okay. A group of researchers are studying the connection between the number of minutes exercise a person performs weekly and a person's HDL cholesterol count. Okay, so you read on, and then it says, after analyzing the data, the researchers found that people who exercise more per week had higher HDL cholesterol counts. Okay, now, because it's more and higher, those are both indicating the same thing. So if I exercise more, my cholesterol, my good cholesterol is going up. So more and up, that gives me a positive line. So this would be considered a positive correlation. And then it says, explain whether the correlation is a result of causation. And I would say, yes, it is. Okay, now, so what does that mean? The more you exercise, the cause of that is a better cholesterol count, a better count on your HDL. Now, that's not direct, it's just inferred that's the cause. So that's what we mean by causation, cause and effect kind of thing. All right, finally, we are going to delve into doing your problems on the homework, and we'll talk about each of these individually in class, and we'll talk about how to implement using your calculator to find your lines of fit.